Good morning. I'm going to go ahead and go over these notes with you guys in case what's there on the paper is a little confusing. Our main focus on here is going to be the formula, which is here. And this is me on the formula. This is what the formula is when we're working with 30, 60, 90 right triangles. You really want to pay attention to the labeling. Of course, when you have your hypotenuse is always across from the 90-degree angle, and then you find your 60-degree angle across will always be x squared root of 3, and this is all going to be based off what's across from the 30-degree angle, the short leg, and it's always your x. That's your foundation. So once you know where your x, you can figure everything else out relatively quickly. So we come and we take a look at our first example. We have our 30-degree angle. It is a right triangle because we all see the 90 degrees. Across from the 30-degree angle is our short side. And we see that our short side has a value of 14. So what this means in terms of our formula is that x is equal to 14. If this is 90, that means across the way is our 2x. So this c is represented by 2x, where our x has a value of 14, which means c is going to equal 2 times 14, or we could say 28. And then our last, this one by default has to be 60 degrees, which means across the way, this, according to the formula chart, is going to be x square root of 3. So we come back to our x value is 14. And so since this is represented by the variable b is going to equal our x, which is 14 square root of 3. So b has a value of 14 square root 3. Okay, taking a look at this next example. Once again, it's a 30, 60, 90 right triangle. This is my 60, my hypotenuse across is the side that we know. So this 12 square root of 3 is, in our formula chart, represented by 2x. So the first thing we want to do is figure out what is that x value? What is this length represented by our 30-degree angle? Okay, so if 2x equals 12 square root of 3, then to solve, we have to divide both sides by 2 to get the x by itself. The 2's will cancel out, leaving us with x equals, and then 12 over 2 reduces to 6 square root of 3. So our short leg, which is represented by the y, I know the letters get confusing, is 6 square root of 3. And then from here, we can scoot everything up a little bit. We can use that information to find our short leg, or excuse me, our long leg, because it's across from the 60. So that's our x square root 3. So if we know now our x value is 6 square root of 3, then to find our long leg of x square root of 3. This is our x. And we need to multiply it by another square root of 3. So it's going to be 6 square root of 3 times 3, or 9. 9, as we said yesterday, is a perfect square, so that comes out as a set of 3s. We multiply and we get 18. So this side here is 18. Taking a look at this last example, we're looking for the area given an equilateral triangle. So an equilateral triangle, we have is a 30, 60, 90 when you're looking at the altitude part, because this would be, all the angles are 60 degrees, but when you have this perpendicular bisector, the top part becomes 30 degrees. So it's a special right triangle. Now the first thing we need to do is figure out the length of the sides, and we can do that because we have our perimeter. So we're going to take this 54 and divide by 3. So the side is going to equal 54 divided by 3, and that comes out to 18. So this is 18, this is 18, it's equilateral, all the sides are congruent. The whole thing here is 18, but when we split it in half, we're looking at 9. And we want to split it in half because we have to find the altitude. So if we look, this altitude is across from the 60-degree angle. Okay, so we're looking at x square root of 3. So we need to figure out what is our x. Our x, from the formula chart, is always across from the 30-degree side. So this is 30. Across the way is 9. That's across from my 30. So x is equal to 9, which means my height is equal to x square root of 3, where x has a value of 9. So my height is 9 square root of 3. Now we can use all of this information to go ahead and find the area. So area is equal to base times height divided by 2. Our base is the whole side of 18 times our height, which is what we found as 9 square root of 3. And we're going to divide this all by 2. Now, I'm going to go ahead and reduce. 2 goes into 2 one time, and 2 goes to 18 9 times. So now I'm going to go ahead and multiply. I get 9 times 9, which is 81. And then we still have our square root of 3. This would be our area. And of course, units squared. Whatever the units are. Inches squared. Okay, so when you're looking at your practice, once again, this is pure practice. So I am not going to collect this for a grade, but you do need to know how to do all of this for you're going to have like a little quiz over this next week. Once again, I know each set looks like a lot, but you're going to end up coming across a pattern when you're looking at all of these. So it says A, B, C. You're thinking, what is my A, B, and C? It is your your A, oops. This is A, B, C. This is the short leg, the long leg, and then we have our hypotenuse. Okay, so what I'm going to do is I'm going to go ahead and label my A here as X off to the side of my first problem set. My B is going to be X square root of 3, and my C is going to be 2X. So you can see, although it looks like a lot, it's really not too bad. So the first one, we're going to go ahead, if X is 6, then that means my B is going to be 6 square root of 3. And then C is going to be 2 times X. So if X is 6, my C is going to be 12. And I'm going to skip over to number 5 in my problem set. So here, X is 8 square root of 3. And then to find my B is going to be 8 square root of 3 times the square root of 3. Well, that gives us a pair of 3's that come out of the radical. And 8 times 3 is 24. And then the C value is going to be 2 times our X. So it's going to be 2 times 8 square root of 3, which gives us 16 square root of 3. So you should be able to finish the first problem set here relatively quickly because of the patterns. All right, I'm going to go and take a look at the second problem set. Once again, I want to go ahead and label off to the side. We have A is our X, B is our X square root of 3, and then C is our 2X. So this one, we have 6 as our first problem, and 6 is representing our X square root of 3. So if I want to go back and find my X value, I'm going to need to solve for X, and this is kind of like a little bit of what we did yesterday. Okay, so I'm going to go ahead, I'm going to use this space up at the top left to go ahead and set up my problem. Okay, so I have 6 is equal to X square root of 3. We're going to solve for X, kind of like what we did yesterday, divide both sides by the square root of 3. And then we're left with our X. I'm going to go ahead and flip it around here. But I also need to rationalize it because we don't want any square roots in the denominator. So multiply the top and the bottom by the square root of 3. And this leaves me with 6 square root of 3 over 3. And that can be reduced to 2 square root of 3. So this would be 2 square root of 3. Okay, I'm going to go ahead and do the next one where the B has a value of 12. And you should, sorry, my baby, you should be able to start finding a pattern. Okay, so my space here is a little limited. So I'm going to go ahead and erase. So I have a little bit more space again to work. And I'm going to use the same top right corner. Okay, so I know X square root of 3 has a value of 12 because that's what I have in my next problem set here. Solving for X, we divide both sides by the square root of 3. What we did yesterday. We're left with X equals, and before I bring this down, I want to rationalize. No square roots in the denominator. So this is going to give me 12 square root of 3 over 3. And those, the 3 and the 12 can reduce, giving me 4 square root of 3. Now I'm going to pause right there because I've done 2 examples, same process. And if you're really good at finding patterns, you should be noticing a pattern emerge. How are we going from 6 to 2 square root of 3, 12 to 4 square root of 3? Hopefully you can use that pattern here to find your next 2 values. If you found it, great. Yes, on number 4, your answer will be in a fraction form. That's okay. If you haven't found it, that's okay too. Just keep on doing some more practice problems and hopefully you'll see it. If not, go ahead and ask one of your buddies to point it out to you, because it'll make your life a lot easier once you see it. Coming back to these C values, I don't want to skip them over altogether. If we know our X value, then we can go ahead and input our 2X value. And here you're multiplying the coefficient of 2 by this 2. So this would be 4 square root of 3. On the second problem set, we have a coefficient of 4. 4 times 2 gives us 8, and we keep that square root of 3. Okay, I'm not going to leave these all in the dark, so let's go ahead and talk about number 5, that first one with the radical. So this 12 square root of 3 is represented by x square root of 3. So if we want x, well, our x is going to be just that coefficient with no radical. And then our c value, we multiply our 12 by 2, and we get our 24. So those are a little bit nicer. Okay, coming and taking a look at problem set 3. Once again, off to the side of my ABC, I'm going to go ahead and put my x square root of 3, and then 2x. So on this problem set 3, the hypotenuse was given to us all across the board. And we're going to go ahead and start out by finding the x. So 6 is 2x, which means x, got to divide by 2, gives me 3. And then my b value, my long leg, would be 3 square root of 3. Same thing with a hypotenuse of 14. My short leg's going to be half of that, making it 7. And my long leg's going to be 7 square root of 3. Skipping over to number 5, where we have the radicals. Same process. If 16 square root of 3 is my hypotenuse, I'm going to take half of that. So I'm going to divide the 16 by 2 to give me 8 square root of 3. And then to find my long leg, I'm going to have to multiply my short leg by square root of 3. And square root of 3 times square root of 3, that gives a perfect square. Those 3's can come out, and then we just do 18 times 3, which is our 24. Okay. So same thing on this one. 12 square root of 3, take half, gives me 6 square root of 3. And then to find the long leg, it's going to be 6 square root of 3 times square root of 3. That gives us a perfect square. So we're really just doing 6 times 3, making it 18. Okay, and then you notice in the last one, this is just kind of a mix of given the short leg, long leg, and hypotenuse. And this is just kind of really reinforcing that pattern, so that way you can go ahead and do the back application part. All right, good luck. Any questions? If your peers can assist you, I will be happy to help out next week on Monday. See you soon.